Hi, welcome to the session on building high-performance apps with in-memory data. I am Ganesh Raja and I'm a specialist solutions architect for data analytics on the AWS platform. In this session, let us look at how Redis can help you build a leaderboard. We will also see some common use cases that we use customers using Redis for. And I will show you a demo of the leaderboard as well. Milliseconds have become the new microseconds. Every customer wants the latency to be reduced. The only way to successfully reduce this latency is by storing and processing the data in memory, and this is really where Amazon ElastiCache fits in. Amazon ElastiCache offers fully managed Redis and Memcache and allows you to seamlessly deploy, operate, and scale popular open source compatible in-memory data stores. Amazon ElastiCache is fully managed, zero administration, no racking, stacking, failover that you have to worry about. And it is hardened by Amazon. And what it means is we have some engineers who are involved with the open source Redis product, and they are constantly looking at the engine, and we enhance those areas that we feel better serve our customers. Redis today is the most popular key value store in the market, and the reason it is because it has a variety of different features. It's a Swiss Army knife. It has a variety of different data structures. So if you are a developer, a lot of these ring a bell to you. Hash maps, lists, sets, and sorted sets. It's very intuitive concerning how you use Redis. In fact, I'd like to think of the API is genius because it's very rich in capability, but syntactically it's very predictable and effortless to use. Other things that make Redis very interesting is that it's a support for HA. So you can have a master or primary or multiple primaries in a clustered environment, and you can fail over in the event of a failed scenario. Another cool feature it has is the transaction support. So you can exclude various commands in a transaction block. Amazon ElastiCache fully supports the open source version of Redis. So from a syntactical standpoint and a protocol standpoint, it's a drop-in replacement with no code change if you're already using Redis. There is always more, right? So other things that Redis has, it has Lua scripts, so you can break in business logic that you can call and reference within your Redis cluster. There is geospatial capability, geospatial set, a particular assorted set that supports longitude and latitude. This is great for mobile applications where maybe you are passing location-based information to the cloud, and Redis, you are looking for points of interest that you want to serve to your end users. There is pub/sub capabilities, so this allows you to build chat applications and notification systems, and it's just built into Redis. So there is nothing that you need to turn on, there is no additional cost, and all these features are available now in ElastiCache. Redis comes in two different flavors. There is two different topologies. The first one is vertically scaled environment, and what that means is you have one primary and your entire key space, which is 16,384 hash slots, they live in that one key space. And so what this means is all your data can fit to the largest size of the node, and in this case would be an R4 16x large, which is 407 gigabytes, and your replicas have the entire copy of all the data. What we provide you is a primary endpoint. Your application could point to that primary endpoint. You also have replica endpoints, and if there was a failover, what would happen if we could take that primary endpoint and we propagate that one of the replicas? So we do the DNS swap for you. With clustered mode enabled, it is primarily a horizontally scaled environment. So you have up to 15 shards. A shard is made up of a primary and 0 to 5 replicas, and each one of these shards essentially own a portion of that key space. So it's a hash slot range, and a default distribution would be to divide the hash slots across the number of shards that you have. So that mostly is the difference between cluster mode enabled and disabled. Now there are other differences. So let us recap a few other things between cluster mode enabled and disabled. If a failover standpoint, because there is no DNS involved, cluster mode enabled is much faster. So if you care about failover speeds, then cluster mode enabled makes a lot of sense, because a failover may take somewhere in the neighborhood of 15 to 30 seconds, And remember, this is on an individual shard. So you imagine you have 3 shards and you had a failure on one of them. Only 33.3% of your data is affected. And if you wanted to reduce that blast radius even further, all you would do is add additional shards. The other difference here is with respect to performance. Because you have the ability to have many shards, you have the ability to write to many primaries at the same time. Because again, a shard consists of a primary and its associated replicas. So from a reading perspective, you have more nodes to interact with. So performance is going to be far greater than cluster mode disabled. The other noticeable difference here would also be storage, because you have more nodes and your data is spread across many primaries. You can have 6+ terabytes worth of data in cluster mode enabled topology. The one trade-off here is cost. Running cluster mode enabled may be more expensive because you have more nodes. However, you are architecting using cluster mode enabled, you are selecting smaller size nodes versus a larger node. But the cost is indeed more expensive with cluster mode enabled, so that would be your trade-off. Amazon ElastiCache in-transit encryption is an optional feature that allows you to increase the security of your data at its most vulnerable points when it is in transit from one location to another. Because there is some processing needed to encrypt and decrypt the data at the endpoints, enabling in-transit encryption can have some performance impact. ElastiCache in-transit implements the following features: encrypted connections, encrypted replication, server authentication, and client authentication. There are many usage patterns for Redis. Session management and database caching are common use cases. But you will also see Redis used for PubSub, IoT, and leaderboards. In the next few slides, we will see how our customers are using Redis. Amazon ElastiCache for Redis is an excellent choice for implementing a highly available, distributed, and secure in-memory cache to decrease access latency, increase throughput, and ease the load of your relational or NoSQL databases and applications. ElastiCache can serve frequently requested items at sub-millisecond response times and enables you to quickly scale for higher workloads without growing the costlier backend databases. When you cache NoSQL stores, you can lower your cost and get a better performance for retrieval of data. Redis can act as a cache for many NoSQL stores, including Elasticsearch, Cassandra, MongoDB, etc. Use Amazon ElastiCache for Redis with streaming solutions such as Apache Kafka and Amazon Kinesis as an in-memory data store to ingest, process, and analyze real-time data with sub-millisecond latency. You will continue to build your data platform on S3, but there may be requirements for transient information to be stored in a fast data layer, and that is where Redis shines. ElastiCache is an ideal choice for real-time analytics use cases such as social media, ad targeting, personalization, IoT, and time series data analytics. We have organizations who are building a solution where they want certain organizations to purchase maybe different packages of how many times you can call a specific API. This is bundled in a package type of deal, and then what they will do is, in their API that the end user will consume, they will make a call out to Redis to check if a particular counter has reached a threshold and start throttling the consumer. Here they use Redis for speed, and they also use Redis here because you don't pay for all those requests. So it makes a lot of sense to do something like this using Redis. To demonstrate some benefits of Redis, we will build a sample sales analytics dashboard using Amazon ElastiCache as well as several other AWS services. We are creating this leaderboard for an e-commerce website. This website is using databases heavily, and they don't want to load any new application on the database. The e-commerce website is a high volume website, and the business needs real-time sales analytics for the current hour and day. The business is latency sensitive and wants the dashboards to display the leaderboards in real time. The metrics the business users are interested in are daily order count, unique items sold, product leaderboards, etc. A sample dashboard is shown here. The data in this dashboard is populated from Redis. The data shown here is exactly how we store this data in Redis, so there is no additional computation to show this data. We will see what types we use to store this data in the demo. Many stores can achieve this, but we chose Redis mainly for the millisecond latency for the leaderboard. Kinesis Analytics does not store the data, and also the queries become quite complex. On the other hand, Elasticsearch would be computationally intensive to perform complex queries. The order system writes orders that are generated into a Kinesis stream. Kinesis streams provide a scalable way to process near real-time data. Lambda functions can consume this data in batches and process them. In our case, we use the Lambda functions to update various Redis keys that will generate the dashboard. We use a Dockerized application running on AWS Fargate, which would serve the dashboard. This application connects to Redis Cluster and reads the data and displays a dashboard. The website uses a socket connection to the Docker application and provides updates in real time to the dashboard. Let us look at this demo to see what is powering this dashboard. Let us log into the Redis cluster. This cluster is running in US West Oregon. So let us go to the ElastiCache console to obtain the cluster endpoint and the port on which the ElastiCache is running. We will use the Redis CLI on the terminal to connect to the cluster using the cluster endpoint and port that we obtained from the console. We can have a look at all the keys that are stored in this Redis cluster by typing the commands keys star to get the list of keys. If you notice, we have a key per day and also key for popular order items. These values directly power the dashboard. Let us now look at the dashboard and see what data is getting populated. On the dashboard, if you look at it, on the right hand side, you would see a connected, not connected button, which basically means, is my dashboard connected to the application to receive data from the application via sockets? Now that it is connected, we can look at the data and see that each of those corresponding boxes on the dashboard corresponds to exactly the Redis keys that we saw. For example, the all-time most popular is a sorted set in Redis, which allows us to score each member in the set and retrieve the data in a sorted order. You can look at the type of a particular Redis key by typing the command redis and key. We will now go back to the command line and open up our Lambda function to see what happens inside the Lambda function. The Lambda function will consume records that are generated on a Kinesis stream, and they update the Redis keys in real time. So orders would be generated and be pushed into the Kinesis stream, and then once the data is in the Kinesis stream, the data would be picked up by the Lambda function, would be processed, and Redis APIs will be called to update the sets. One of the Redis APIs that we call is updating the Z set, the sorted set, which I am highlighting here. Now let us go back to the dashboard to see how these records have changed the dashboard. You notice that we are constantly having a flow of data coming in, and the data is constantly getting updated on the dashboard. In this demo, you saw how Redis could be used to power a real-time dashboard. So if you were to take a second to think about your data from a temperature gauge, The hot data would be that data that you access most frequently. And if you thought about the characteristics of the hot data, what you would want it to be is the ability to support incredibly high request rates, very, very low latency, and that's basically where Amazon ElastiCache fits. And as data volume grows and sort of the data starts getting warmer and colder, you will see other data stores kind of fit in. If you are building a data platform, essentially what you want to do is you want to think about your data access patterns, and you want to utilize the different data stores and databases that make sense for that specific data volume and access patterns. Some caching tips. The first tip, understand the frequency of change of the underlying data and what is the impact of providing stale data. If the impact is high, then be conservative. If there is a minimal impact, use your best judgment here and work with your database administrators and your business owners to understand what value makes sense. Second tip, set the appropriate TTLs that match the frequency of data change. Third tip, choose the proper eviction policies that align with the application requirements. Fourth tip, isolate for the purpose like database cache and queue cache. Don't have them in a single cluster. Fifth tip, main cache freshness by doing write-through. This will also ensure you don't serve stale data to your users. Sixth tip, test, test, test. It is critical you performance test and size your clusters appropriately. Seventh step, create alarms so that you are notified of bad performance cache hits and misses. Eighth step, work backward from failure. Always test the resiliency of the application using the failover APIs provided by ElastiCache. To gain hands-on experience with AWS, please watch our instructional videos and explore the self-paced labs. You can also attend our instructor-led classes and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. You can get more info by visiting the URL http://aws.amazon.com/training. AWS also has a wide partner ecosystem to help you focus on your success and take the full advantage of all the business benefits that AWS has to offer. Learn more about how APN partners can help you. Find the right APN partners for your needs by visiting the AWS APN booth at our showcase. Thank you for attending the session. We hope you found it interesting. Do provide us with your feedback and let us know how we can improve the event experience for you in the future.